Geosynthetics have been utilized in numerous civil and environmental engineering applications worldwide for more than 20 years to prevent seepage of liquids. Such seepage control applications as water containment and conveyance, structure waterproofing, and environmental protection make extensive use of geomembranes and geosynthetic clay liners, along with other geosynthetics. Materials used for seepage control may be exposed as with pond linings or buried as with landfill linings. They may be subject to significant stresses as with a pond cover or exposed to very aggressive environments as with a chemical tank lining. The wide variety of potential exposure conditions is why there is such a wide variety of geosynthetic barrier materials. Material selection and installation details are therefore project specific.
Now, here are some examples of geosynthetics in seepage control systems. First, waterproofing. The protection of structures, even soil and rock structures, from the effects of seeping water is a common need. As noted in Chapter 3, this need is typically addressed with a drainage layer, often accompanied by a waterproofing layer.
Hi, and welcome to DryShield Water Solutions video on external waterproofing and internal drainage systems. I'm going to walk you through how drainage systems function on existing foundations. The ground is excavated for installation of the foundation. Footings are poured and foundation walls are installed. The floor is then installed on top of the footings. Originally, weeping tiles are installed at the bottom side of the footings. Typically, a damp-proof spray is applied, not a waterproof membrane. Excavated soil is then backfilled, however, it is not as dense as the soil that was not excavated. When it rains or snow melts, water will find the excavated angle and travel back towards the bottom of the foundation. This is why weeping tiles are installed at the bottom side of the footings. Once the weepers clog, the water will begin to build on the outside of the foundation, causing hydrostatic pressure. Once the pressure builds, water will enter at the floor wall joint, either from underneath or over top of the footing. Over the past few decades, our research has allowed us to incorporate the highest level of waterproofing technologies and procedures to date. Let us show you how the external procedure is installed. The soil around the foundation is excavated. The weeping tiles are removed and the walls are cleaned. Small holes are drilled into the bottom blocks to remove any moisture in the wall. The walls and footings are coated by hand with the highest quality rubberized urethane. Poly sheeting is applied on top of the urethane and dimple board is installed with steel brackets and a finishing strip. New weeping tiles with a geotextile filter cloth are installed and connected to proper drainage. 3/4 inch clear gravel is installed on top of the weepers to a minimum of 1 foot depth. A geomembrane filter cloth is installed on top of the gravel. This will prevent the soil from clogging the system. Soil is then backfilled and graded away from the foundation. With this installation, DryShield provides a full 25-year transferable warranty on all external waterproofing. Depending on the situation, a more cost-effective approach can be done from the inside. The latest technologies allow for proper internal drainage systems. The key to water seepage is drainage, regardless if done from inside or out. Our internal process involves exposing the foundation to the concrete, and in some cases, the removal of drywall, studs, insulation, and flooring. The concrete is then broken 12 to 14 inches from the foundation wall. A trench is dug to expose the inside of the bottom footing. Weeping tiles are then installed and graded towards the sump pump. 3/4 inch clear gravel is installed over the weepers. A waterproof membrane is then installed over the weeping tile, extending to the top of the foundation wall. New concrete is poured over the system, flush with the existing slab.
Taking advantage of their sheet-like nature, geomembranes and GCLs can be used to isolate water-sensitive roadway soils and subgrades in order to maintain the soils at their desired water content. They are also quickly and easily deployed as protective covers over material stockpiles to prevent wetting and erosion. It can also offer a more economical, less installation-intensive alternative to clay barriers. GCLs also take up less space and are somewhat resistant to freeze-thaw and wet-dry cycles.
Water supply preservation. Water containment systems. The containment and protection of important water supplies is a challenge to public works agencies as well as to industry. Effective lining of potable water reservoir can conserve millions of gallons of water by preventing seepage losses. Additionally, covers can prevent contamination, control evaporation, and prevent chlorine loss. Water conveyance systems. The prevention of seepage from line and reline canals is critical in arid regions. Similarly, stormwater retention and detention facilities are lined with a geomembrane or GCL to prevent excess wetness or instability of surrounding property resulting from seepage of contained runoff.
Geomembranes serves as effective protection against evaporation and contamination and can prevent seepage losses when used as liners and floating covers. Though generally used in more highly engineered installations, their low cost, widespread availability, and relative ease of installation make geomembranes and GCLs more and more popular.
Environmental Protection System. The increase in environmental sensitivity of the last 2 decades has led to important regulation requiring de minimis leakage of contamination to the environment from landfills and other waste deposits. Additionally, as soon as a landfill reaches capacity, it must be capped to minimize future leachate generation.
Geomembranes and GCLs makes them technically superior to any other alternative for providing a positive barrier to the movement of fluids and gases. There are many ways that geomembranes and GCLs have been incorporated into environmental protection barrier systems, including final covers over waste materials, liners for solid, hazardous, and monofill waste landfills, liners for lagoons and other surface impoundments such as geothermal, aquaculture, solar, or specific chemical ponds. Secondary containment for underground storage tanks. Vertical barriers to contain subsurface contaminant plumes. Horizontal and vertical barriers to radon and methane emissions. Pit liners for the collection and recycling of leach solutions from ore piles or even manure piles.